Mischa, thank you. One off with the microphone.
Thank you. Imagine the internet 20 years ago. Okay, so how was that? Some of you probably weren't really operational at that time. I was, and the internet back then was for me a very simple thing. I was actually in my dorm putting Ethernet cables. It was a very physical experience, right? I had my computer on the desk, a very old machine, but the actual internet for me was to go out there and start hammering the Ethernet cable on the room, through the dorm, to get it connected to the internet, this new thing, all right? So that was it back then, 20 years ago. Now you zoom forward and you go 2015, you go out in the street and ask the kids what the internet is really for them today, and the answer will be Facebook, right? LinkedIn, Twitter, Amazon, eBay, whatever. It will be opportunities. So we've undergone in the last 20 years a massive transformation from an internet which was very, very infrastructure-based, Ethernet cables and all that, to one which suddenly is totally opportunity-based and business-based. And we've totally forgotten the underlying infrastructure. When you switch on your computer, do you still think about the Ethernet cable which is connecting that? You don't. You've just forgotten about this. That's really massive. So it took 20 years to get this going, a long time, but we're here now, and we're building this next generation type of economy on top of that internet. So we didn't stop with a fixed internet, actually. We started evolving that type of internet, and I want to tell you a little bit about the story where we are in terms of the evolutions. So we came then, we started designing the mobile internet. Okay, so the mobile internet is really what actually my cup of tea is. So this is all about wireless. We started a few years back with 2G, which I think was a great success from an engineering point of view. We then moved on to 3G, which was a full disaster and only was chosen from a technology point of view because Qualcomm and NTT Docomo were the first ones to actually put a working system on the table before anybody else was able to react. So they said, 3GPP said, okay, that is the type of system we're going to go for. So we started designing this 3G system, UMTS, and those who are skilled in the arts, they know it's a real disaster from a tech point of view, okay? So I remember 2000, I was involved in a startup back then here in London, trying to come up with algorithms which would allow power control, which would allow dimension of cell briefing, which would allow essentially dimension the whole 3G system. We didn't manage. Just 2 mobiles in the system kind of worked, but anything beyond that, it was just totally blow up. So 3G was a little mistake. 4G is a great system, okay? Now 4G isn't actually up and running. Maybe those who are not skilled in the arts, they wouldn't know that. Even though you see the very little logo on your mobile phone saying 4G, it's actually not 4G. They've been cheating on you. So we were kind of really waiting for many years before we said, hey, let's call the next system 4G. There's a huge standards body called the ITU, which determines what is 2G, 3G, 4G, 5G. And the ITU in 2000 has put out these requirements, IMT-A, IMT Advanced, which are the 4G requirements. And the current system, which is labeled 4G, is actually not meeting these requirements, okay? We all knew that, so engineers know that. The marketing departments lost patience and said, hey, let's call that 4G, right? So 4G, though, is coming. 4G is just a very small add-on to the system we have currently running. It essentially relies on carrier aggregation, okay? So instead of you taking just a 5 megahertz chunk of spectrum you're currently using, you would lose 10, 15, 20 megahertz. And EE and Vodafone have recently demonstrated download rates of 1 gigabit per second, okay? Gigabit per second. This is more than what your Wi-Fi can do at home. It's massive. It's really massive. So my current system, which I'm using, my LTE system, long-term evolution system, when I get on the train down to London, I use 4G. It's exactly the same experience as if I used a computer. Exactly the same experience. That's really fascinating. We managed to actually build a system which gives us a fantastic user experience. Well, the more you come into London, you get a lot of congestion, so it kind of breaks down. Most likely you're being downgraded to 3G, back to the system, which is kind of a disaster, okay? And then you get annoyed again with the operator, etc. Rarely you go an outage. But this is what essentially we have done over these years. And if you look at the requirements we have been drafting, that's very pertinent to 5G. When we started designing 3G, we didn't have the internet. But actually, we didn't, right? So we're still, we're still hammering Ethernet cables through on this planet. That's what we did. So we started designing this 3G system when we didn't have the internet. We started designing the 4G system when we actually didn't have iPhones, okay, which is new. We had this inkling there must be something for which this type of system is useful, but we didn't know. iPhone came along, and suddenly 4G made sense, okay? And now with 5G, we really struggle to come up with good scenarios, like literally, really. I'll show you one scenario here, which comes out of actually some of my early days in Barcelona. So there's a company which actually offers cameras for football players, all right? So the idea is that Messi would be wearing that camera on the field, and along with his 21 other players, okay? And we would see in real time what's going on in the field. This is brilliant. So you could literally participate in this footballing experience, would totally change how things go. Now, because that needs to be real time, we can't put compression on top. That is raw data which needs to be fired into the system. So suddenly from those amount of cameras, only 10 here, raw data, 100 hertz frames, so high resolution, suddenly you end up at 100 gigabits per second, okay? That is massive, so 4G can't do that. So we really need to go to the next stage. Now, having said this, so once you start actually talking to the stakeholders, you figure out actually real time is not needed. When people sit in a stadium, they want to see the action on the field and just 6 seconds later see it on the mobile phone. So you've got 6 seconds. 6 seconds is enough to encode your data and decode it. So probably you can get this data rate down to probably a gigabit per second, and then it's just broadcast, okay, or multicast at worst. So in fact, with a 4G system, LTE system, you could probably do that. So I bring you back to this. We're not worried about this. So we really struggle. We really, really struggle with coming up with scenarios in 5G which would really warrant this 10 to 100 times higher capacity we need to get things going, okay? But again, coming back to what I said before, it's not troublesome, because with 4G we had the same thing and 3G had the same thing, and hopefully there will be applications which will require that. Okay, so now we're on 5G, and the 5G slides you see generally circulating on this planet in keynotes, tutorials, and all that, they all look the same actually. Okay, so when it comes to data rates, always factor 10 or factor 100. No difference. In fact, no difference between them, and no difference to the 4G slides. As a matter of fact, there's even no difference to 3G slides. Okay, so I have a running joke with Gerhard Fettweis saying that I can give a 5G keynote using 3G slides and nobody would realize. Yeah? So today I will not expose you to that, but it's doable because in fact what we're only doing is we're essentially improving data rates by factor 10, factor 100. And to do that, we need systems which John alluded to, millimeter wave system, very heterogeneous type of setting to get this type of scenario going. But let me call that the traditional evolution of the mobile internet. Traditional, because data rate is really what we have been pushing in the last 20 years. Okay, so this is business as usual. As we go from generation to generation, we want to improve the data rate factor of 10, factor 100. Okay, some people say, those who are superstitious say 2G was a really good system, 4G was a really good system, 3G sucked, 5G, well, you do the numbers, right? So we'll see whether we need 6G to really get it off the ground. Anyway, let's go on. The other internet we designed is the Things Internet, okay? So also known as the Internet of Things. But I purposely called it the Things Internet because it goes from fixed internet, mobile internet, to the Things Internet. Now we start to connect things, right? Objects, sensors, actuators. The fact that this thing is actually on a 5G slide is a mystery. It's a bit of a mystery, right? It's a bit of a almost you can call it a historic mistake because we have been doing this for the past 30 years. Okay, people called it differently. Maybe it started with smart dust, then Zigbee type of systems. So why isn't it up and running yet? The same way as I said before. Okay, we're still talking about sensors. We're still talking about radios. We haven't actually talked about the Twitter for Internet of Things. We haven't talked about Facebooks for things, right? So we haven't done this transformation. We haven't even started that transformation, yeah? So we're still talking about infrastructure. Too much, in my opinion, and we've been talking about this for far too long. So what's gone wrong? What's gone wrong that this is now in a 5G slide where it actually shouldn't be at all? So what's gone wrong is that around 2000, we kind of realized, hey, we need a system which would allow me to kind of scale up to billions of sensors, billions of actuators, if not trillion, and it should run on batteries because you can't really change battery for so many devices, okay? At least, I'm recharging my mobile phone once a day. You can't really do that for billions of devices in the street. So, okay, so IEEE was chartered to come along with a really good engineering design, low power to connect billions of systems. We came up with a great physical layer. We came up with a great medium access control. We came up with a great routing layer. We came up with a great, application layer on top. I was involved in some of that. I was founding member of quite a few standards buddies there when I worked in Orange on that. So I was really inside. I believed in this system. I was bleeding the system. I loved it. It's known as the Zigbee system with different variants, wireless hard, wireless M-bus, IEEE 802.15.4e, 6-low PAN, roll, co-op, etc. It's all great, wonderful. The only problem is it actually never really worked. Okay, that was quite a little problem here. Because it was designed by engineers who love technology, who love engineering, but it wasn't really designed by people who know how to run a business. And so we ended up with that Zigbee type of system, which now we have, 15 years? Have you seen any massive Zigbee rollouts? You haven't. They're not there. I was in Orange when we did that, right? In 2007, we offered a Zigbee dongle to be offered with a Wi-Fi box, which is called the free box, so people could power their home Zigbee network to make a smart home. 2007 didn't pick up because we just forgot about one little thing is to do a link. You need two ends, not just one. There was no fridge speaking Zigbee. There was no toaster speaking Zigbee. There's nothing speaking Zigbee. So maybe today you have the toaster speaking Zigbee, but then you don't have the access point. So to make a link, you need both. And what the marketing advertisement and the market prediction companies do wrong, they say, hey, we sold billions and trillions of chips, but, just to sell a chip doesn't make the connection. Look at your Bluetooth. How many of you use Bluetooth? Raise your hands. Right? So that's 60% out of the average statistics. Okay, there's not more. But if you count to the actual prediction how the M2M internet evolves, they would count all the Bluetooth chips, even though we never switch them on, the majority of us. It's a problem, okay? We've been following the wrong predictions, and it's gotten worse. I started rolling this out in one of the biggest smart city rollouts in the world, and it wouldn't work. It wouldn't work because Zigbee, once you actually need to cover an area, which is a bit larger than our personal area, for which it works quite well, you need multi-hop. You need mesh networking. It's great for academics. They can publish infinitely, ad hoc networks, Varnese, etc. Nobody can challenge you because the assumptions are just not verifiable. So many degrees of freedom. There's no way, right? So with loads of papers, 99.99% of which will make absolutely zero impact on the commercial uptake whatsoever, okay? So here we are. It didn't work. I had to hire 2 engineers full-time to babysit my IoT system, which had been developed with millions of engineering hours, costing billions of dollars, just so the network would work more or less, right? So we started rolling out 100 nodes, loads of problems, infinite amount of problems. So I told my CEO back then, we stop with Zigbee, doesn't work. I love the system. I've been part of the standards community. I've been bleeding the whole system from the inside, but it's just not ready. And probably will never be ready considering how many people have actually spent time developing it, right? So that was in 2010. We found a company which would do things differently, and that essentially bootstrapped the whole market. Things got going. I'll tell you in a moment why. But I want to tell you before the mistakes we realized back then. We believed the engineers that we need a low-power system. Now that is categorically wrong. We need a high-power system. Low power gives you low range. High power gives you high range, okay? Low power means mesh networking to cover a city or a building, okay? High power means star topology, single base station in the city, covering all the sensors in the city, right? Does it make sense? Now, how do we get now to the low battery consumption? Well, you need to remember that actually it's not power which is draining your battery, it's energy. So what we need is a high-power system with low energy consumption. Can we do that? Very simple. You remember your school days. Energy is power multiplied by time. So the only thing we need is a system transmitting at high power, doing the job very quickly, going back to sleep, and just sleeping until it has to transmit something again. Right? Mistake number 1. Mistake number 2, we believe the ISM band is a great band to be in. I agree. Time to market is very quick. There's very little actually regulation on the ISM band, so the band which Wi-Fi uses, okay? In reality, if you want to run a business, it's a totally different story because there's no quality of service guarantee on there. So if I'm starting to instrument something really critical, imagine a patient with a heart monitoring device. Imagine a refinery, an oil refinery monitored for pressure, right? Imagine something really critical happening. I need to transmit that packet. The packet cannot be transmitted because the ISM band is congested because somebody is watching Netflix, right? Person dies, refinery blows up. Who's responsible? I'm responsible. I go to prison because I provided this technology. It's a real problem, service level agreement problem, legal problem. Nobody looked at that. Loads of other problems, so I don't want to go into too many details, but there's one other problem, which is the total cost of ownership. Because what really drives deployment is the total cost of ownership and not the chip cost. What we were looking for in Zigbee design so much is to come up with a chip which is really, really cheap. Very cheap, right? So Zigbee chip off the shelf, with the whole microcontroller itself, for $1.50 you can get that today. Bless you. Now what I actually need to pay though is not 50 cents because for my 100 sensor network rollout in the city, I needed to hire 2 engineers full-time, $100,000 extra per year. So suddenly my chip is not 50 cents but $50. Okay? So you see the difference. Total cost of ownership totally changes the game. So it turns out that putting a cellular modem into every single a sensoring chip I had for the smart city rollout would have been cheaper overall than using the Zigbee solution. Okay, so that's what we realized, the 3 mistakes, pretty massive mistakes. So other technologies realized that, and we ended up with a really beautiful system called Sigfox. So these are the type of low power wide area networking systems. 2010, nobody knew of them. I drove to Toulouse, met Ludovic, who's the CEO. By the way, if you get to know him, he's really crazy. He loves Porsche. He takes you for a ride. He almost killed me on the road. But here you go, wonderful chap. And he said, hey, Mischa, you know, what we need is this long-range system. And before I tell you more about it, let me tell you about the capability. So my company, World Sensing, pioneered the concept of smart parking, and we use it in our smart parking nodes. Once an hour, our smart parking node sends a beacon saying, hey, I'm alive. You know, that's a battery level, that's the occupancy status, etc. Now, when my CEO was landing in Paris, okay, he was landing in Paris, the beacon was sent from the airplane landing, was picked up in Barcelona. 900 kilometers, okay? 900 kilometers line of sight. Contrast this to Zigbee, tens of meters, Wi-Fi maybe 100 meters, cellular maybe 2-3 kilometers, right? 900 kilometers. These are link budgets which would allow you to talk to a satellite. That's what Sigfox is doing now. They're hoping to instrument essentially the whole planet, anything which is not too real time, just talk to the satellite and relay it down back to Earth. And that would essentially allow a total global ubiquitous coverage on this planet. Nobody knew them back then. I gave in 2010 a keynote at Etsy in Sofia Antipolis in front of all the Cisco crowd. And because Cisco invested a lot in multi-hop networking, the same as I actually invested with Orange, it's the only time in my life I gave a keynote that the guy, during the keynote, stood up and heckled me and said, this is all bollocks what you're saying, okay? 2010. Zoom forward 5 years. Cisco is now leading the Low Power Wide Area Alliance. They love the technology. They still put in Zigbee, but what actually drives their business model is exactly what I predicted 5 years ago, because I told them Zigbee will be dead, okay? So here you go, maybe exaggerate a little bit, but here, my point is that there are other technologies out there which are much more powerful. So in the city, we are instrumenting single base station covering the whole city, covering all sensors, works just fine. Sigfox is a great system, off the shelf with a software-defined radio base station, designed by the Motorola guys who were fired by Motorola in 2009 when the Paris labs were resolved. Okay, so this is how history plays back. Then another friend of mine, another friend of mine founded the company called Cyclio. Cyclio is a French startup, or was a French startup, doing the same thing, long-range, low-power wide area networking capabilities. They were acquired by Semtech. Semtech is Europe's largest chip manufacturer, and currently they're powering the LoRa Alliance. So there are new systems coming, and they're really zero-headache systems. Me as a CTO back then, I could just go, hey, let's focus on the actual end-to-end technology and forget about the wireless interface, okay? So we moved on. Then there are other systems came out, like low-power Wi-Fi, okay? Because there was a company in 2008 called Osmo Devices, which before the iPhone really took off, people still used normal cameras, okay? This was before your time in a sense. And they claimed they came up with a system where you take a picture and it's being uploaded directly to your Wi-Fi box. And the AA batteries, which were in the camera, would last exactly the same amount as if you didn't have the wireless interface. And everyone was like, excuse me, 2008, you remember those days? You switched on Wi-Fi, your battery was dead in half an hour. So it's kind of, something is wrong here. So what they did is they actually looked at the 802.11 protocol specs, went through all the language and figured out that there is something called a duty cycle, DRX, right? So you can switch on and off your radio. That's what they did. Optimize the silicon, optimize the protocol, and build a Wi-Fi compliant system which would really be actually low energy. And they made it really work. And now they're offering, and other companies, these type of products. IEEE loved it, and in their tradition to do a lot of IEEE.11 salad type of standards, a new standard was born, 802.11AH. AH is a playing field of very different players, so there are things which actually don't belong together, but one part of the standard deals with how do we connect to a single Wi-Fi spot 6,000 sensors with really low energy. And they're currently ratifying this standard, so we are now in revision 2. First product's going to come by the end of the year. And next year, most likely, we're going to have low-power Wi-Fi chips, which allow you essentially to put into your IoT solution that chip. It would connect seamlessly to any Wi-Fi radio you authenticated to. Isn't that beautiful? So we don't have to carry around this Zigbee base station gateway anymore. It's just there because everywhere where you are on this planet, there's Wi-Fi. Everywhere where you really want to measure things, there's Wi-Fi. And if they're not, you just plug it in. It's there. It's very easy to understand. People understand Wi-Fi. Go out in the street, ask about Zigbee. Nobody knows what it really is, right? So it makes a big difference. So here you go. Okay, but we still have one problem, and that's a problem of scalability. So we are not sure whether low-power wide area networks would really scale into the trillions of devices. Don't know, no idea. We still have the problem with the service level agreements, okay? Because all these systems, low-power Wi-Fi and low-power wide area networking, operate over license-exempt spectrum. So there's the problem of accountability. So cellular came back into the game. That's why we put it back on the 5G slide. Because suddenly cellular realized, hey, what Zigbee promised for 15 years, we can do this much better. We can connect B2C. We can business to consumer type of product, your armbands, etc., your fits, how do you call them, Fitbits and stuff like that, right? Your B2B, so business to business type of products like traffic, oil and gas, etc. Much better than what we have in the control industries. So we are back. The only problem, of course, is by the time this system is up and running, 2020, earliest, 2023 most likely, the whole Internet of Things market will probably be gone already. We'll find another solution, okay? So the community kind of almost panicked, and what happened last year is very interesting. There's a British company called Newell, which was founded by a whole classroom of people, so loads of co-founders there, some 30 people, most of them very good friends of mine, and I've been pushing them for 6 years to send me a working chip, which in the end I never got, okay? Curiously, though, even though they didn't have a single working system and they didn't have a single customer, really, they were acquired by Huawei for $25 million. Isn't it great? So there's hope for you guys, right? So here's the story. What happened is Newell recognized what I just said. Newell said, hey, let's go to the license bands. So they went to BT. They did a trial in Milton Keynes where they took their license-exempt low-power wide area networking technology and shifted it into the licensed spectrum, right? Very simple to do from a technology point of view. They wouldn't use exactly the GSM or UMTS bands, but they would use the guard bands where nothing happens really, okay? So this is where they transmitted the stuff, worked really well. Vodafone got to know about this, and because Vodafone understood, hey, you know, if we develop a 3GPP native type of machine-to-machine type of communication solution, will take too long. Let's fast-track technologies through the standards bodies. So they did this essentially. They said, hey, 3GPP, look, we got Newell here. We want to fast-track that technology within your standards body, okay? Huawei also bought into this, and naturally there's a huge uproar in July last year in the 3GPP meeting, because the traditional players which were there holding the fields, you know, the Nokias and the Alcatel-Lucent, etc., didn't like this at all, like not at all. It's their playing field, okay? So they started to negotiate, and by September it seemed kind of they started to resolve the thing, and this is when Huawei acquired Newell, because they've seen there's a potential of actually pushing this through. Now zoom forward, June 2015, a year later, we have 3 technologies on 3GPP's table today, which are very similar. So Newell type of technology, Sigfox type of technology, and LoRa type of technology. They're all on the table now to be fast-tracked. Fast-tracking means you're not connecting the technology at the very end in the packet gateway, but you're actually injecting it natively at the wireless edge, right at the eNode B. So the idea is to have an eNode B, and at the beginning have an alien eNode B, a small IoT eNode B, just beside, running whatever system is there, and then authenticate this and inject it right at the edge into whatever you have, Cloud Run, whatever you have there. It's a total shift, okay? We're accepting alien traffic now into the system. It's not the first time we're doing this, so we are kind of used to that from our community side. So we got femtocells. Femtocells do exactly the same thing. They happen to use the same interface, but because it's a consumer-driven thing, it's kind of alien to the operators in 3GPP, but we still inject it at the very edge. We use protocols like LIPA, local IP access, stuff like this. So all what we did as a community may just prove very, very useful to fast-track any of the technologies I just described to you in 3GPP, okay? At the same time, of course, the big players are continue developing their native type of radios. So we are working to this, for instance, with the University of Surrey together. So literally the idea is, and this was Surrey's idea, to come up with something which is really zero complexity, right? Totally like zero complexity at the edge, machine-type communication devices. And the idea is not to, the problem is not because we don't have silicon to put in some complexity, but complexity comes with IPR, and IPR comes with cost, okay? So to keep the cost down, we just have to have zero complexity here and absorb the complexity rather than the network, okay? So there are kind of new ideas coming. We're exploring that, but how far we can go, we don't know. We really don't know. So we don't know how well this will scale. For the time being, to take the Newell, Sigfox, etc., seems to be like a very safe bet. So here we are. It shouldn't be in here, but it is here. And also to finish this off, for the mobile operators, just to give you a feeling on what it means in terms of business. TeliaSonera is one of the most progressive operators on the planet. They introduced, as a matter of fact, the bundling of cellular and Wi-Fi, because before TeliaSonera, when I was in Orange, for instance, we would actually slow down Wi-Fi developments, right? Because we didn't like it. Cellular didn't like Wi-Fi until TeliaSonera came along and said, hey, you can bundle that. You probably don't remember these days because you always were used to have the Wi-Fi and the cellular kind of together. But it wasn't like that 10 years ago. Anyway, TeliaSonera, they're rolling out aggressively machine-type communication, so Internet of Things for various reasons in Sweden. And they also have a lot of people their service for the data plans and calling plans. So what they do in terms of revenues in a single year, okay, in a single year with the Internet of Things, they do with the people in 2 hours. Okay, we're talking about exactly the same amount of SIM cards, no difference. Okay, so in Sweden there are loads of things you want to instrument and not so many people. Same SIM cards. The business for IoT 1 year to get a certain revenue, the same equivalent 2 hours with people. So if you're the CEO, tell me what you would decide. You would take everybody out of IoT and put everybody on a human type of traffic, right? There's no business here. So we need to think here how to flip that. Because if the operators don't buy in the story, there will be no things internet in 5G. No way. We can talk about it as much as we want. Academia can push as much as we want. Startups can push as much as they want. Vendors can push as much as they want. If the operators like the Oranges, the Vodafones don't buy into this, end of this game. It's very simple. Okay. Next thing, we thought, after the fixed mobile and things internet, we could do a bit better, and that's really what we're excited about. This is very early. We're designing a new internet here, which hopefully will be rolled out in 2030, 2035, and the idea is to transmit touch, right? So once you can transmit touch, which we currently can't really do, and explain you why, once you can transmit touch, you can transmit skill. Once you can transmit skill, you can transmit labor. And you have an ability to essentially remotely transmit labor. You can have a skill set transmission network. You can have the United Kingdom, which is a very skill set driven country, apply all its skill set all around the world. So imagine voxel engineers servicing a car in Africa while it's not leaving actually London. Imagine a surgeon in London doing Operation Sierra Leone remotely. Wouldn't that be great? Imagine me teaching a child how to play the piano remotely or being taught how to do it. So these are the type of capabilities we can do with that, okay? And that's all about this tactile internet. A real breakthrough, and we have worked quite a lot on the tactile side. So there's loads of sensing solutions out there. If you go in the robotics community, there's a lot of stuff here. A lot of haptics is happening. Some of that has been connected, right? So no problem. So we had an early version of the tactile internet already for quite a few years. But it is nothing else but like our telephony circuit switch network we had in the 1960s. What we want to build is a true internet. Okay? What made the internet so true internet is because A could talk to B, B could talk to C, C to A. Bidirectional, packet switched. Okay? We had a few ingredients in the internet which really made the internet, and we want to replicate this right here with touch. Because currently, I cannot take a Siemens glove and have it communicate with an ABB medical surgeon engine. You can't do that, right? Because we lack essentially different skills on both ends. I'm going to tell you a little bit more from the engineering point of view what it means. And one of the things we definitely need to achieve is extraordinary low delay. That's probably the biggest challenge. It's less the rate, it's less the tactile side. It's literally this low delay. Why is that? Because if you shake somebody's hand, you apply an action, and you expect a reaction. You feel that, right? So that has to happen within a millisecond. Studies have been conducted in the 80s which have confirmed that if the delay between action and reaction is more than a millisecond, we just go totally haywire, right? We go dizzy. It's called cyber sickness. We're just hardwired for millennia to feel essentially, to be very reactive, very quickly reactive. So within a millisecond, we need to have that touch back. Otherwise, you just go, whoo. People who do gaming, people who do flight simulators, they do know that. So you need to get a lot of stuff up and running here in very, very short time. That's all good, right? It's all good. There's only one little problem, really. To make this happen from a networking point of view, we need to break the laws of physics, okay? And here's a reason why. So 1 millisecond, speed of light in fiber buys you 200 kilometers, right? So if you want to have something action and reaction, it's 100 kilometers to go, 100 kilometers to go back. So how can a voxel engineer service a car in Africa, a surgeon somewhere else on the other end of the world really do a real-time operation where you do something and you get the feedback back in real time? It's kind of impossible, okay? It's really impossible. So we need to come up with solutions which go beyond the typical hardcore engineering design. So we need to come up with a clever solution which would allow us to do that in a very scalable way. So I want to go into too many technical details, but this is essentially what we're doing at the moment. And Kostas is one of my PhD students here. We're working on this. We're working with Ericsson on that and a lot of other people on this planet. So here's essentially the graph. It's the only technical graph I'm showing you today here. So this is the human operator. This is me doing whatever, a surgery or touching somebody. That is, on the other hand, where this is being replicated. So it's a teleoperated slave robot. And you have essentially a wireless domain here. It's going through the packet gate, eNode B, which is there. Let me see if I can get to the actual. So it goes to the eNode B. Goes to the serving gateway, packet gateway, goes out of the operator's network, goes into the internet, goes through, comes back into another operator's network, packet gateway, serving gateway, eNode B, and then the actuation, and all the way back, right? So we need to do that in a millisecond, for them back. How do you do that? Well, so what we said is that what we realized, a lot of the skills we transmit are very repetitive and quite predictive. Okay, so I remind you, we don't need to predict what you're going to do in the next 5 minutes. We just need to predict what you're going to do in the next 50 milliseconds or 20 milliseconds, right? We're just buying essentially time from 1 millisecond to 20 milliseconds. It's not a big deal. This is like if I move like this, probably, you know, something like this, or even less than that, okay? So it's very little movement here, which we need to predict. So what we say is, hey, we're going to put predictive engines on both ends. They're going to predict how things go based on past observations on a very short window. Once in the real world, I'm seeing that prediction differs by a certain amount of epsilon. I'm updating coefficients, transmitting it back to the actual teleoperator device. And by the time this becomes delta, it's being recorrected back. And this delta is just before damage control. Okay? And the time you gain because of that is exactly the time I need to buy essentially the time around the planet. So if we can push this to 50 milliseconds would be great, but then we need new air interface, an air interface which is not congested, so that's why 5G comes in there. New Cloud RAN architecture, which literally quick streams all the information for the core network. New fiber infrastructure altogether for the internet, because we really want to make sure a packet that's been generated in eye surgery actually reaches properly the patient on the other end. Otherwise, it will be a disaster, right? So loads of engineering challenges there, but once we manage, I think that will be a massive breakthrough. The other thing we're working on quite a lot, because we want to ensure that this is very standardized, the same way as the music industry and the video industry has taken off. We're designing currently tactile codecs, right? The same as there exists a video codec and a sound codec, because we believe that's the only way to get this industry going. To have essentially tactile codecs allows you to have any endpoint talk to any other endpoint and would allow you different streams to be meshed up. So you can imagine one surgeon doing one type of surgery, another surgeon doing another type of surgery, all together mashed up in a single stream, put on top the audio and video file and just transmit it through the internet. And these are the challenges which are ahead from a technology point of view. And quite exciting, and 5G plays quite a role, particularly here in this part here and maybe in the core networking part if we still decide to keep it. Yeah? All right, so now making it happen. Making it happen is the big challenge. So I told you a few things on what should be done. Making it happen requires a few things. So this is quite a painful section because it requires a little bit departing from the normal way how we do engineering. Yeah. So I think we need a totally new way to think about technology. We need a totally new way of thinking about the cellular systems. Just about the delay. Just look at the delay, nothing else. I'm not talking about data rate or outage, whatever. Just look at the delay. How it is constructed at the moment. My mobile phone, when I do a call, goes to the eNode B, so the base station somewhere in the building on the roof. Okay? That signal goes to the serving gateway. From the serving gateway, it goes to the packet gateway, and only then it goes out in the, into the general public domain. Okay? So imagine I wanna call Costas, right? He's just right here, happens to be next door. He is on Vodafone, I'm on O2. Give him a call. Imagine we're in Edinburgh, because London's not a good example, but imagine we're both in Edinburgh. I give him a call, goes essentially serving gateway, packet gateway, eNode B serving a packet gateway goes out, goes back into Vodafone network, comes back, right? Now, what very few people know is there are not so many packet gateways, not so many of those. So typically, LTE would have, and an operator in the UK would have 3, maybe a maximum 5 packet gateways. So no matter how you arrange them, it can always happen that you're really very far. The worst of the case is, just for me making a call through the wall, 10 meters, my call is being routed down to London and back up to Edinburgh. Okay, you do the calculus with the delay we just get from the physical transmission of the signal, it would blow the whole idea of the tactile internet. So the core network is a problem. It's really a problem. There's a real problem with that thing. And we do have a core network in the 5G discussions because we had the core network in 4G. And we had the core network in 4G because we had it in 3G. And we had the core network in 3G because we had it in 2G. And we had the core network in 2G because back then nobody believed that the internet we were designing would be able to deliver what we wanted to deliver because we were still nailing Ethernet cables and dorms. Okay? That was the actual rationale why the core network appeared. The functionality of the core network are great. Billing, authentication, mobility management, quality of service guarantees, it's all good. But how it is constructed, it holds back a whole lot of applications. Yeah? Because the internet has evolved now much quicker than my cellular backbone network. You see it yourself. Those who live in London, downtown London, they know. If I try to make a phone call using my cellular system, chances are it will not work. Okay, so pretty much with a very, very high reliability, I can make sure that my call is either being rejected or being dropped. It's just over-congested on the interface and the core, etc. I try to make a Skype call with video for 1 hour on Wi-Fi, no problem. Okay, so you tell me which community did really implement quality of experience. So here you go. And it goes all back to the core network. So one of my personal missions is to get rid of it altogether because I don't think we need it. Been talking this now for 2 years. I got a lot of stare blanks 2 years ago, but people get used to the idea. And Alex here in the room, we're exploring loads of ideas to see how can we thin it to the point that it just disappears altogether. Having injection points, getting native Wi-Fi called in, etc. So we need new ways of handling with this technology to make the tactile internet and other internets possible. The other big headache is standards, right? So standards, I was recently in December asked to keynote here the digital economy catapult about how can you innovate? How can you build startups within the cellular ecosystem within 5G? And I really struggled. Because I'm an academic, I know a lot about cellular, but I'm also an entrepreneur, so I know a lot about entrepreneurship. And it just didn't fit. It just didn't fit. So I was very clear about this in the keynote, which upset a lot of people. This is what I do. And I told them, look, if you're an entrepreneur, you see 3GPP or cellular, this is what you see. A big, clunky iceberg. How do you innovate in this? How do you really build, a startup on top of that or even within that? There's no way. It takes us every time 10 years to come up with a new system. People say it's getting shorter. It's not really true. 2G took 10 years, 3G took 10 years, 4G took 10 years, 5G will also take 10 years, which is obvious because you need antenna manufacturers, handset manufacturers, baseband manufacturers, eNode B manufacturers, operators, billing, serving gateway, packet gateway, authentication, routing, quality of service management. Everybody has to agree. And it takes a long time to come to an agreement. And that's why we take 10 years. And that's why cellular, compared to the actual internet, lags behind, always by 1 or 2 orders of magnitude, right? So when the internet offers us a gigabit per second, cellular will offer us 10 megabits per second. And that's the reason. You don't see Facebook, Intel, and Cisco sit together every 10 years and come up with a new internet, do you? You don't. Everybody's evolving. Everybody has their own playing field. They have the world of Pandoras, as I call them. That's what we want. Small, well-defined worlds within which we can innovate with very clear connections between these worlds. So I've started propagating this idea as of December last year and met by chance the CTO of Etsy, Adrian Case, and it turns out I was not the only one kind of thinking we should change that. So he's experimenting currently within Etsy, one of the bigger standards bodies on the planet, the one who came up with GSM, as a matter of fact. Now, they're saying, hey, why don't we just totally change the way how we do standards? He's looking now into crowdsourcing, he's looking into distributed type of e-meeting, so just to accelerate the pace of innovation because we're lagging behind. The wireless interface, which now absorbs 50% of the traffic, is lagging behind. And 5G will be yet another story of this lagging behind. And if you really want to accelerate things, get rid of Gs. Okay? So no 6G. Can we do that? Let's work on that together as a community. I made my other big goal. Just get rid of Gs altogether. So here you go. Standards, we need to change them, and hopefully something will happen. And with the IoT being fast-tracked now into the 3GPP buddies, with native Wi-Fi calling coming, you see there are big changes. There are very big changes. 3GPP is not quick enough anymore to do things. They're doing great jobs. Okay, they're doing a really great job. It's the only system which is built globally. No matter where you're on the planet, you can make a phone call. There's no other system like that, right? The internet and the mobile internet. That's it. So we designed that. It's very, very tricky. But we need to get up to speed now with times. Now, the last point I want to make on how to make this happen is about flipping the business models, right? So I show here a child where they're often flipping themselves. They see the world in a very different way. Clearly, we understand we can't continue cellular in the way as we did over the past years, right? So it's business as usual, unfortunately, doesn't work. And we have been, as a community, and I have been warning about this now for maybe 2.5, 3 years. Of course, you always get blank stares until something major happens. And that happened in April. So I ended up now suddenly in the 3C board level meeting rooms with CTOs and CIOs of one of the biggest vendors and telco operators on the planet. Everybody's panicking. And why? Because Google announced Google Fi. Okay? Total game changer. Doesn't seem a big thing. They probably will not pursue it. We're all clear about this. But Google Fi is native Wi-Fi calling, right? So no matter where you are, I can call your normal cellular number And if you are not on a cellular interface, but on a Wi-Fi interface, you will get this call as if it has come through the cellular system. It's called native Wi-Fi calling. Total game changer. Why? Because we spend 80% of our time indoors. 80% of the time is indoors. When we're indoors, there's Wi-Fi, literally everywhere on the planet, right? So 80% of the time, you're actually on Wi-Fi. And only 20% of the time, you need literally to go out and need the current cellular infrastructure. So with Google reaching you now 80% of the time, what they can do is use the current regulatory requirements by governments that, you know, a natural operator like Vodafone, Verizon, need to sublease their lines for virtual mobile network operators. Google becomes a mobile virtual network operator just to cover the other 20%, okay, small thing. And the actual bulk of traffic is handled indoors. So suddenly they will have all your data, they know where you are, what you're watching, and Google just becomes one order of magnitude bigger, okay? And the operator suddenly will not be anymore talking to you. They will be pushed out of the whole game. They're gone. Okay, so the actual customer for the Verizon and the O2s will not be you. It will be the Google, Sky, Talk, whatever. So it's a total shift here, and they understand that as a big threat to their business models. That's number one. Number two, with the Internet of Things coming, particularly the industrial Internet of Things coming, there's potentially another big opportunity to make money for the operators. But operators spend no time on talking to the General Electrics, talking to the Schlumbergers, talking to traffic companies, healthcare companies. They don't do that because they spend most of the time talking to you, which Google now talks to you much better, right? So they forget this world a little bit. And you see vendors like Cisco, Ericsson, and other players actually locking themselves into very heavy verticals. So you see the CEO of Ericsson talking to the CEO of Skanska. Skanska is the biggest construction company in the world. Suddenly they're instrumenting, they're providing actually the Internet of Things type of sensor network, and that will flip totally the model. Why is that? Because currently the operator is procuring the cheapest vendor, which offers, you know, the minimum type of service, right? So they say, hey, you know, Huawei, Ericsson, Alcatel-Lucent, etc. What is the cheapest you can do to do our minimum requirements? So they're all competing. The vendors are all competing to get the best deal and lock themselves into the operators. With the Internet of Things, suddenly it's the other way around. Because the Ericsson are already locked into the verticals. They're already in Skanska. Skanska will not talk to TeliaSonera or to O2. They will ask Ericsson, hey, you know, provide me the whole connectivity thing because you have been kind of dealing it from a digital point of view. And then Ericsson will say, okay, who of the Vodafones, O2s, and Verizons is the cheapest one to give me the best deal? Okay? So they totally flipped the model. Suddenly, as of 2015, the operators feel, hey, wait, we're kind of in the back foot here. We're losing our stronghold, which is not a problem. They're essentially shifting from a strong B2C model, business to consumer model, into a very strong B2B, business to business model, which I think is not a problem at all. So my company operates in B2B. It's a good market, different models. Just get used to that. So maybe by 2030, the traditional operators as we know them will just totally disappear. Let's see. Let's see what happens. But we clearly need to see how we get along with the whole business, IoT, ARPU, etc. So I'll leave you with that to think a little bit. Now, for me to finish off, what I want to do is I want you to listen to some people, okay? Because what I like to do is before I start something new, I try to keep it really real. So I talk to people, if they like things, if they would use it, etc. So I went out to the streets of London and asked people about would they use the tactile internet, this ability to touch through the internet, the ability to transmit skills and labor through the internet. Would you actually use that? So I went out in the streets and asked people, so listen for yourself.
Not exactly sure what I'd use it for. I mean, I'd like to feed blogs, so there could be some possibilities about touching the feed, but not quite sure how that could work.
It's amazing. I think if we could do that, it'd be like really like incredible, and you could use it for anything. You could use it to like save people's lives. Like it could be like the next big thing. It could be like life changing, like amazing.
the kind of working with my hands is very important, and also encouraging other people to kind of work with their hands. My work is quite participatory, and I use things like clay and concrete from building sites. So that sort of tactile nature to the work that I make is quite interesting. So the ideas you've just kind of suggested to me, I'd be really interested to see how that kind of develops, because although it's kind of less tactile, but it's still kind of how you could sort of use your hands across the other side of the world like that is quite an interesting thing to think about.
Yeah, I think it's a great idea. I think the restrictions on internet at the moment are that you can literally share visual and audio content, but it's really difficult as a design person to actually get your hand aesthetic across via the internet if it's not something visual or audible. I think Krista and I, currently, if we're trying to work on a sculpture together and I'm in a different country, or Chris is in a different country, or even just a different place in the city, we'll send pictures and we'll be like, does this look right? Is this one right? And we'll have to do the sculpture many times, whereas if we could actually physically
do it through the internet.
Do it through the internet. So I could control Krista's hands, or even just what you could, I don't know, like do different stuff. I could be like, not like this, more like this, for starters. And then I guess, if we were sort of branching out into other unseen territories, if we were on a different planet, we could start to, I don't know, manipulate or to create something in a different world that perhaps the human couldn't go to, I guess.
Well said.
Yeah, I think it's a fantastic idea. In my industry, I work finance-wise, but the industry actually I work in, media, and TV, post-production, I think it'd be absolutely fantastic. I really think it'd be beneficial for them.
Yeah. So, as a creator of video series Digital Futures, which focuses on tech for good, I tend to keep a really close eye on advances that have the capacity to impact our day-to-day lives. The tactile internet, for me, is certainly one of them. If we can see and hear things that aren't close by, why shouldn't we be able to feel them, right? To be able to use data networks to relay actual human touch would be surreal, and it's attainable. To me, I think the biggest reason to get excited about this is the potential for health and education. Then you've got the marrying of the two worlds of AI and the tactile internet. You could remotely control humanoid robots who would be performing surgery or other public services. It's the immersive nature of something like this that really lights my fire.
Well, I would play some games, and I might want to play in there instead of up there. It would be so nice when you touch your dad when he's traveling, and then you can go through the computer and say hello and keep a while with him, and then you can kiss him, and you can kiss him.
All right. Again, it took a child 6 years old to realize what we'll be using the technology for to essentially in 2030 bring peace and prosperity to this planet. I'll leave you with that. Thank you very much.